All right. Well, thank you for the invitation. And yeah, I think very few people know my name. I think I maybe should just change my name to Weather Tiger at this point for the brand recognition. But when I was at Trinity, I was still very well known for my weather. Well, the weather. I don't think I surprised anybody with my choice of career, but I hope that I'm living up to the expectations of what people would have wanted out of me as a professional weatherman. So, when I was at Trinity, I was a huge nerd, and I was well known for always being in the library, always having the latest. Hey, how's it going? Always having the latest hurricane information, always hoping for school cancellations. And people would always ask me my forecast, and I think that's a really interesting thing when you're a forecaster to know what you can say and when you can say it. It's a tricky kind of balancing act. You have to say something that's worthwhile, something that has value to the end user, but you don't want to overstate and be overconfident. So that's kind of what this talk is about. What can we say about hurricanes every step of the forecast process, from months before hurricane season to right down to the minute as it's happening, what we can say about it. So I want to start by showing some pictures of young Weather Tiger back in the Trinity days in the beginning. You can see that picture top left is a tracking map that grocery stores used to hand out at the checkout. Every year they'd have a different tracking map, and when I was a young nerd, I would draw the individual hurricane points on that map and keep track of it. As a Trinity student, I'd bring my maps in and show them to people some who were and many who weren't interested in them. But I did that every year while I was in high school. And really, hurricane seasons were pretty quiet for Orlando while I was at Trinity in the late 90s and early 2000s. And it wasn't until after I graduated that things got really busy. So the big storm that kicked things off in Central Florida was Hurricane Charlie in 2004, which ripped across Central Florida on August 13th, Friday the 13th, 2004. So you can see me bottom left there. I'm running through my neighborhood holding hurricane flags to let the people know what's going to happen. You can see the radar loop on the night of the 13th. And that eye wall came right across Central Orange County, Central Seminole County, basically right over Trinity. And Charlie was still a Category 1 or 2 hurricane as it crossed over Winter Park, and it did major damage to trees. Power outages were lasting a week or two. Huge oak trees were down. That's a picture from my house. And you can see that swath, those kind of orange colors indicate the area that got hurricane force winds sustained out of Charlie in 2004. And it runs right through Trinity, right through my house, just a little north of Trinity. So that was a real turning point for me. I'd been a weather hobbyist. I was very interested in weather, but I wasn't sure if it was what I wanted to do professionally as a career. But Hurricane Charlie kind of set me on the path of doing that professionally, especially with all the other storms that happened in 2004 and 2005, and people asking my opinion and then starting to pay me for my opinion as I got a little older. So I decided I got an undergraduate degree in geosciences. I went to Princeton. They didn't have a meteorology program, but I took a lot of earth sciences as much as I could there. And then I went to FSU, and my plan was, okay, I'm going to get a meteorology degree at FSU, get a master's in a couple years, and then go full-time as a kind of an agricultural meteorologist. So that was the plan, and what actually happened was I did get my master's degree, but I stayed for my PhD. My preliminary qualifying exam was delayed because I got accepted to be on Jeopardy. So that slowed things down. I got to meet Alex Trebek. Didn't win, but I gave it my best shot. Got married. Gotten a couple houses in Tallahassee, started a business. I have 2 kids who've been through pandemics, hurricanes, and have been spending the last 15 years here in Tallahassee off of a 2-year plan. So that was a little bit of my professional background and how things happened differently than I had planned. Since Weather Tiger was founded in 2015, I've built a national brand where certainly a strong brand within the state of Florida. Obviously, I've got my newsletter that goes out through Substack, but all those commentaries are also printed across all the USA Today owned papers across Florida, Florida Today, Palm Beach Post, Jacksonville Times Union, a lot of other ones. I've had commentaries published in the Washington Post, and I'm frequently interviewed on Bloomberg and other sources of hurricane and agricultural weather news. So people know in North Florida, if you see me on CNN, it's going to be a pretty bad day in North Florida or in the state of Florida generally, because I don't get interviewed when it's calm weather. I don't get interviewed for good news. So that's kind of a thumbnail of what we've built at Weather Tiger. I've got the agricultural side of the business, the hurricane side of the business, and then I do some kind of legal consulting work for weather cases that involve insurance claims where weather's kind of at question. So I kind of meteorology work too. So 3 legs of the stool at Weather Tiger. It's a fun industry to be in. It's always different, always changing. And most importantly, it keeps me from getting bored, which was my goal in life. Don't be bored. So I want to move ahead to the question of really the central question. It's almost a philosophical question. What is forecasting? Well, at Weather Tiger, my goal is to turn kind of this abstract profusion of data that exists, all this kind of raw information, into predictions that are useful and usable for the end audience. That can be for the person who's trading agricultural commodities, the farmer who's trying to decide when do I sell my corn or my soybeans, or the person trying to decide when do I pull my boat out of the water at the marina. Do I need to evacuate? Am I going to need to cancel school today? That's all these questions. We need to turn this huge amount of information and data into something that a decision maker can use to make an informed choice. So you got to limit the information that's going into that decision-making process. Just generally, there's so much data available in so many different forms these days that you kind of have to develop a process of turning that information into something that can be used to make a decision. So for me, I've got a forecast funnel. On the base of that triangle is my scientific training and from academics, graduate school, the real world observations of what's going on in real life. My intuition from having done this over a long period of time, climatology, the hurricane history, some expert insights from the National Hurricane Center, and then the reliable computer modeling that's really advanced in the past 20 years and is so much better now than it was a couple decades ago. Outside of the forecast funnel, you got to ignore the noise. You got to ignore, I never read the comment section on any of the times where my articles or news articles are posted on Facebook. You got to kind of step away from what will happen at my house to what will happen in a broader sense. And you got to ignore models and theories that aren't reliable or untested or don't have a background record of success. So, it's always a question as you go forward with time, you can move new models, new information into the forecast funnel and make that decision basis on a case-by-case basis. But you got to have a way of filtering and differentiating information these days because there's just so much of it, so much noise if you're not turning the volume down. So that's kind of the basics of at any stage what I would use or what I do use to make my decisions as a forecaster. But for hurricanes specifically, there's a few different types of forecasts that we can get into. Really 4 time frames where you can say something and that it's kind of limited by what your information and what your historical skill of those forecasts are. So those kind of ranges of time are 1 to 6 months ahead of time, and then getting within a period of time where there's a lead time of weeks, a lead time of days, and then a lead time of hours. So months, weeks, days, and hours are sort of the general time frames that you can structure your forecast communications differently. And that's something that really has to go into every forecast, is what you're communicating to make sure that it's being understood by the end user. So the first time frame I'm going to talk about are seasonal forecasts. So seasonal forecasts mean anything from 1 month ahead of time or longer. So this is kind of the time frame that we're in now when we're considering what the 2024 hurricane season is going to be like. So fundamentally, the question that you're trying to address in a seasonal outlook is, will a hurricane season be quiet or busy? So these are two maps of the hurricane activity over the course of the entire hurricane season. At left, you have the 2015 hurricane season, and at right, 2017. Well, no one remembers the 2015 hurricane season because there was relatively little activity, only a couple of major hurricanes, and nothing that really moved towards land of any degree of significance. 2017 is still the most destructive hurricane season of all time. You had Irma, you had Harvey, you had several other impactful storms on the U.S. Gulf Coast. And it was a very busy hurricane season with 6 major hurricanes, 2 of which made landfall in the continental United States. So can we sort these 2 seasons out ahead of time using clues from the ocean or atmosphere? And a little more subtle question, can these 2 seasons be sorted out ahead of time using ocean and atmospheric clues? This is a little bit harder. At left, you have the 2010 hurricane season, and at right, you have the 2020 hurricane season. Overall, the amount of activity in terms of what's called accumulated cyclone energy, or ACE, was about the same between these 2 hurricane seasons. They were both busier than average. But in 2020, you had 3 major hurricanes make landfall in the continental U.S., many other events that were impactful for the continental United States. And in 2020, you simply didn't have any significant tropical impacts on the U.S. whatsoever. Storms stayed out to sea. They moved westward through the Caribbean and hit Mexico or Central America. So for U.S. forecast purposes, differentiating between these 2 seasons is important as well, because what we really care about are impacts. What we really care about are it's going to strike an area where a lot of people live and a lot of insured property. Those are what really influence the societal impact of storms. So for seasonal forecasting, there's a couple tools in our tool belt. For one, you can use what are called analog methods. You can identify hurricane seasons of the past that have shared kind of important precursor characteristics. So you can look back and say, okay, well, the 2024 hurricane season, it looks like going into it, share some similarities with 1998, share some similarities with 2010 and 2020. And you can look back and see how those seasons played out. And then, kind of project that maybe more or less with some degree of variability, that might be what you get this year. You can also use seasonal climate models, which are essentially the same weather models that we see for shorter term forecasts, just run out to longer periods of time. They're not trying to forecast weather on a day-to-day basis, but in aggregate, sometimes they have skill in showing where sea surface temperatures are going to be warm or cool, or we'll have certain atmospheric circulation patterns at certain times a year. So those go into the forecast as well. And then predictive analytics, that's something we push really heavily here at Weather Tiger, kind of our own blend of forecast modeling, statistical modeling that isolates the most important and skillful predictors ahead of time for the season, and it kind of puts them together in a way that offers the highest degree of skill in forecasting the season ahead. So why can we forecast at this 1 to 6 month time frame? Well, a couple reasons. One is because the biggest reason is that water does not change temperature very quickly. Water has what's called high thermal inertia, which means you can't pivot sea surface temperatures on a dime. If you've got a big area of the Atlantic or the Pacific that's significantly warmer or cooler than average, it's a reasonable assumption that it will stay that way for at least several months at a time. And oftentimes, in certain cases, say the equatorial Pacific, it'll stay that way for a 6 or 12 month period. So I'm sure you've probably heard about El Nino and La Nina. That is a key driver of global weather patterns, because those sea surface temperature anomalies in the central Pacific Ocean, they will persist for at least 8 months, but sometimes 2 or 3 years at a time. And that gives you more predictability on their influence that they're going to have on the way that the weather patterns will shape up worldwide over that period of time. So oceans are slow to change, and you also have these climate modes like El Nino or La Nina that are very influential and last for sometimes years at a time. That gives you the ability to say something about the season ahead. So, for instance, I discussed 2017 and how busy a hurricane season it was for the continental US. Well, if we looked at sea surface temperatures in early August, so just before the the most active part of hurricane season, you can see that there's a kind of warm horseshoe of water across the tropical Atlantic and then arcing up towards southwest Europe, and cooler than average sea surface temperatures in the central and eastern Pacific Ocean. So that's that top map. That's what the sea surface temperatures were in early August 2017. The bottom map is a correlation map that shows how sea surface temperatures historically varied with the activity of the season ahead. So those blues that you see in the Pacific, those are areas where colder sea surface temperatures were linked to more tropical activity in the heart of the hurricane season. And the reds that you see in the tropical Atlantic, just the opposite. Warmer waters, more hurricane activity to follow. So the fact that we had something in 2017 that looked very much like it's warmer where you would want it to be warmer for activity. It's cooler where you for an active season. In general, that's what you're looking at to determine whether your seasonal outlook. And there's fancier things that you can do with this, but those are kind of the basics of it. And the reason why the Atlantic and the Pacific both matter, and we have to look at both of them, is because they do have a significant relationship with landfall activity in the continental United States. So this top bar graph breaks down the Atlantic into cooler in blue, near normal in gray, and then warmer in red regimes of tropical Atlantic temperatures. And then the bar graph is plotting the average number of major hurricane landfalls in the continental US. So when the Atlantic is warm, we see an average of about 3/4 of major hurricane making landfall per year, about 3 major hurricane landfalls per year, 4 seasons where the Atlantic is significantly warmer than average. For cooler than average seasons, that major hurricane landfall expectation is about 1 major hurricane every 4 cooler than average seasons. So I do want to point out that we're not having the same number of seasons in each of these bins. There's fewer cool seasons, and that's because the Atlantic has been warming with time. So if you're averaging, you have a 30-year moving average of sea surface temperatures that's regarded as normal. If you have a warming trend superimposed on that, you're going to have fewer seasons that are cooler than that 30-year average due to natural variability. So obviously, climate change does have an impact here as well, in kind of influencing that risk distribution. Now, if we go to the bottom panel, this is the Pacific. This kind of breaks down the influence of the Pacific Ocean. And it's just the opposite. The La Nina events that are marked by cooler than average Pacific waters, you see about 3 major hurricane landfalls every 4 La Nina seasons. In neutral years, it's about 1 major hurricane landfall every other season. And in El Nino years, it's about 1/3 or 1 out of 3 chance of a major hurricane landfall in an El Nino year. So that's a big swing in the risk. And when you have a situation where you have a warm Atlantic plus a La Nina, that's your highest degree of landfall risk approaching the season. You can't say anything about where or when those landfalls are going to occur, but you can kind of say in a broader sense, yes, we're at above average risk of impactful hurricane activity going into the hurricane season. Now, unfortunately, both of those most active bars are very likely to be the conditions in place for the Atlantic hurricane season in 2024. So this is a map of what sea surface temperature anomalies were, the difference between the current sea surface temperatures and those 30-year normals. As of about a month ago, things have changed a little bit since then, but really the core features of the map have not changed. In the hurricane formation zone of the Atlantic Ocean, there's record warmth. We've never been warmer in the tropical Atlantic at this time of year than we are in 2024, by a long ways, by 1/4 or 1/3 of a degree Celsius, which is a huge amount to break those kind of records over a very, very broad area of the ocean. So the takeaway from that is even if that record warmth does not keep up, we're very likely to be warmer than average in the tropical Atlantic during the heart of hurricane season in August, September, and October. Now, we are still in El Nino conditions. We see those warmer waters across the central and tropical Pacific. Those oranges and yellows indicate that the El Nino event that was in place over the winter of 2022 or 23, 24 is still in place. But you can see you have some of those blues are popping up off the west coast of South America. And those emerging cooler waters signal that we're likely to get the summer development of a La Nina event, possibly a quite strong one as we head into the peak of hurricane season. There's very cold waters just beneath the surface of the Pacific and a thin layer of that surface warmth that's going to be going away within the next 4 to 6 weeks. So I expect by the end of summer, we'll likely be in a La Nina event that'll be strengthening into the fall. And that's, of course, favorable for Atlantic tropical cyclone activity. Makes the El Nino kind of means, or the La Nina means that there'll be more favorable upper level winds than average over the Western Atlantic, and that record warmth will be offering lots of potential energy for hurricanes to take advantage of as they transit the Atlantic Ocean. So putting that into our predictive analytical model that we've developed in-house at WeatherTiger, that means that there's about an 80% chance of what we would call a hyperactive 2024 hurricane season. Essentially, that means that you would get about 2/3 more activity or more than an average Atlantic hurricane season. So it would be in the top 1/6 of seasons. And there's about an 80% chance of being in that top 6 of seasons since 1950. That means a total of about 20 to 24 tropical storms, 9 to 12 hurricanes, 4 to 7 major hurricanes. Long-term averages for those are 14 tropical storms, 7 hurricanes, 3 major hurricanes. So well above normal is our range. And there's a 55% chance of 3 or more U.S. hurricane impacts, as well as a 70% chance of at least one major hurricane landfall in the continental United States in the 2024 season. That's against a historical average of about a 40% chance of one major landfall. So it's not a certainty that we're going to see repeated major hurricane landfalls in 2024, but certainly we're looking at those risks exceeding that of an average season. And kind of what this plot shows at left is what's the cumulative probability of exceeding certain Atlantic activity ACE levels during the hurricane season. Black is kind of the background climatology, the historical distribution of hurricane seasons, and orange is our probability distribution for this year. The most likely value that we have on our forecast map is a 50% chance of having about 200 ACE units, which would be about double normal hurricane activity. And there's about a 10 or 15% chance of actually breaking the record for most accumulated cyclone activity in one hurricane season. So these probabilities are something that I update every day during hurricane season, and you can go to weathertiger.substack.com and check out how those probabilities are changing day by day. So to sum it up, a seasonal forecast is something that can give a warning of whether the season as a whole will be more or less active than usual. And it can kind of drill down a little bit into landfall risks as well. That's something that I've really focused my research efforts on, is making it not just be, is it going to be a busy or an inactive year, but will that busyness or inactivity be near or far from the continental United States? So, there's a lot of error bands around that. It's probabilistic. The uncertainty is high. It also does not factor in that it really does only take one hurricane to make it a bad year. 1992, a very quiet hurricane season, other than Hurricane Andrew, which was a Category 5 hurricane landfall south of Miami, one of the worst hurricanes in history for the state of Florida. So, strengths, we can make a skillful forecast ahead of time. It does have skill against just guessing or picking history, but you just have to keep in mind that there's a lot of uncertainty around that forecast, talking about how things will play out in September when it's April. The next scale of forecasting that we can look at going forward is something that's really kind of emerged as a forecast discipline in the last 10 or 15 years, I would say. Something that's called sub-seasonal forecasting, and that's the time frame I would call weeks of lead time. So anywhere from 1.5 to 4 weeks worth of lead time. So what can we say about what the hurricane season is going to do over the next 2 to 4 weeks? Well, you start to get into the range where seasonal climate models become a more skillful tool for forecasting. They're not just kind of guessing what's going to be 6 months out. Now you're getting into the range of where they do actually have, on a week by week basis, some ability to say, where the jet stream is going to be aligned over 3 or 4 weeks out. Not always, but sometimes. So those seasonal climate models are a tool, and also the historical relationships between certain pre-existing patterns that are in the atmosphere and kind of have these time frames where they're relatively predictable on 4 to 6 week scale. So once again, we're looking at sea surface temperatures and El Nino and La Nina. Those are important. Initial land conditions, like how dry the soil is in a given environment, can also influence weather 2 to 3 weeks out. And cyclical oscillations, these waves that originate in the tropical atmosphere and then propagate from west to east in a relatively predictable way, do give us an additional source of forecast skill. So what I'm showing here, the blue areas are areas of the tropics that are getting more rain than normal, and red areas are seeing less rain than normal. And what you'll note in this 48-day loop is that you see these areas of enhanced rainfall activity generally moving east out of the Indian Ocean and then moving into the Central Pacific, followed by another wave developing behind it. And there's kind of this relatively predictable pattern of wet and dry conditions in the tropics that influence when tropical waves are more likely to develop. So this is an interesting thing to look at. These waves are called the Madden-Julian oscillation, or MJO. There's 8 phases of the MJO, and there's a strong degree of prediction or predictability. In certain MJO phases, we really are favoring development, and we're favoring more damaging landfall and tropical cyclones in the continental U.S. So this is an image that Dr. Phil Klotstock at Colorado State University, a good friend of mine, he plotted the net damage in the continental U.S. from hurricanes by phase of the MJO. So in phases 1 and 2 are pretty favorable for development of tropical cyclones. And then as it goes into phases 3 and 4, things that develop in phases 1 and 2 sometimes move towards the continental U.S. So you see this big difference in phases 1 through 4 have a high degree of historical damage, dollar damage to the continental U.S. Phases 5 through 8 that are less favorable for tropical cyclones only have about 40% of the net damage that the more active MJO phases do. And these are all spending about the same amount of time in each phase, so it's a fair comparison. So these MJO phases have a lot of predictable value. And the way I use this kind of in real time as a forecaster is I'll be monitoring these MJO phases and cycles, seeing if there's not always a wave that's identified in the atmosphere that's going to roll from west to east in a predictable way, but when there is, it gives you a little extra ability to say what's going to happen going out a long way. So prior to Hurricane Michael approaching the Florida Panhandle in 2018, another Category 5 hurricane, the only other Category 5 hurricane in the past 80 years to strike Florida, other than Hurricane Andrew. What I said in a column a couple of weeks ahead of time was that a southeast ridge was going to develop. We'd have a pattern that would open the door for a tropical threat to the Gulf Coast in the 2nd or 3rd week of October. And I said this in late September. And I was able to do that because the MJO was kind of lining up in a way that looked like things were going to be favorable in the Caribbean and the Gulf of Mexico going out into mid-October. So that subseasonal forecast scale, we're still really trying to, as meteorologists, wring the most predictability that we can out of those predictable propagation of waves. We can identify broad regions where tropical activity is more likely or less likely than normal. Maybe regions where there's enhanced or diminished landfall risks as well. But we're still not predicting specific storms. And you can't always have something in the atmosphere that's going to give you that skill even 2 weeks out. Sometimes 2 weeks out is a total mystery. Sometimes the next 3 or 4 weeks look pretty locked in, and we can say more about them. So, as a forecaster, you always have to calibrate the message you're communicating to not be overly confident, give people a sense of skill. And ultimately, the purpose of that is to build trust. So you know that when you're communicating something confidently, your audience can take it to the bank and they can make a decision and act on it. And now we're going to get down into the range where we're more in the realm of making decisions based on the forecast data. And that's what I would call the medium range, or days ahead of time. So 3 to 9 days of lead time. Now you're getting into the range where we can say more about what the weather is actually going to be day by day over the next 10 days. You really cannot go out further than 10 days and make a forecast of what the weather is going to be on any given day. I don't care what AccuWeather says, their 51 or 93 day forecast. It does not have any skill over just history. Maybe you could add in a little bit of skill with El Nino, but it's a gross misrepresentation to say that you can predict whether it'll rain 73 days from now or not. You cannot. You can only say that kind of information about 10 days out. Now you're getting into the range 10 days out where global weather models that we're more familiar with, things like the GFS or the European model, the UK Met Office model, Canadian model. These are ranges where now we have more forecast skill. Day-to-day prediction of weather is something that we can do on that time scale. So this is an example of a huge cold outbreak that happened in 2019. About 10 days ahead of time, you had the European ensemble forecast model showing a deep trough over the eastern United States, big cold air outbreak, very likely to take place. And then what you see on the bottom panel is that's exactly what happened. That's kind of the verification, the validation of that model. It came in exactly right. It really was exactly correct in putting the ridges and troughs, the nooks and crannies of the jet stream flow. So ensemble techniques are maybe something you've heard about, something where we've really been able to push that day-to-day forecast skill forward in the past 20 years. Ensemble techniques are essentially we're tweaking the initial conditions of the model. We're making very small changes to what the model is taking in as its initial input. And those small changes, because of chaos theory and what we call the butterfly effect in popular culture, you can have big differences in what the models are saying, 10 or 14 days out. So if you average a bunch of model runs together with each that have slightly different initial conditions, just simply because we don't know exactly what the atmosphere is doing at any given time, we make a good guess, we make our best guess, but it's not perfect. And if we kind of represent the uncertainty in that forecast a little bit better by repeating that forecast model run 50 times instead of just doing it once, and then looking at the average, looking how it spreads out going forward with time. So the things that are providing our predictability, our skill at the medium forecast range days out, are what is the weather doing initially. That's a huge huge input. Getting an accurate snapshot of what's happening in real time has been a major advance in our forecast technology. It's really responsible for a lot of the improvement in forecasting. And the other advance is that we've made progress with the forecast models themselves. We have more computational power to throw at problems. Moore's law, we're increasing our computational power. We're doubling it every 18 months or so. Well, you keep doubling the computational power of your supercomputers, you can have much finer grid spacing in your forecast models. You can have more realistic physics governing how air masses are interacting, how heating and cooling and clouds are all interacting with each other in these very complicated mathematical ways. Solving those differential equations is not easy, but we can do a lot more of them with increased computational power. So for the purpose of hurricanes, you can see this improvement in forecast skill in the average error of a National Hurricane Center forecast decade by decade. So that's what this figure at left is showing. Each decade is the average forecast error in nautical miles going back to the 1960s and forward to the 2020 through 2022. Final numbers are not out for 2023. We can see is that each decade, that forecast error gets lower and lower. And we can also make forecasts that go out farther. We only made them out to 3 days. until the late 90s. And now in the last 25 years, we make 5-day forecasts. They may expand that out at the NHC to 7 days at some point in the next few years. It's something they're looking at internally. And the reason why we can do that is because the forecast skill in the 20 teens, for instance, in a 3-day forecast, you have an average error of the 3-day NHC forecast point of about 100 nautical miles. Well, that's about the same amount of forecast skill as a 24-hour forecast was in the 1990s, or even more than that, going back into the 80s or 70s. So we've really moved the forecast time frame and our forecast confidence up so much by improving our forecast modeling, improving our data collection, and computational and mathematical improvements account for that. So returning to the example of Michael, what does that model data look like in real time? So this is the output from the European Ensemble forecast model for early October 6th, 2018. Now we have a disturbance over Central America. There's actually something that we can look at satellite and say there's a disturbance out there that some of the models are latching onto as potential development as it moves through the Western Caribbean and then into the Eastern Gulf of Mexico. So each of those lines represents one ensemble run from the European ensemble. So some of them are taking this proto-Michael towards Louisiana, some are taking it towards the Florida Panhandle, and some are not developing it at all. But we have a range of possibilities for actual weather events on the border. So I'm looking at the data. What did I say on my forecasts on that day? Well, kind of weighing the different data inputs, the models, observations. My assessment here was that somewhere along the east central Gulf Coast was likely to see a hurricane landfall in the midweek, 3 to 5 days. Western Florida Panhandle at greatest risk could go further east than that and then go into the Big Bend. And this is what actually happened. This is Michael's forecast track, and you can see it kind of hit in the central Panhandle. So 3 or 4 days out, I'm not saying it's going to make landfall in Panama City. I am communicating a range of possible outcomes so that people within a swath know how to prepare, know to be alert, know to continue monitoring the forecast, and be ready to act to preserve life and property if the forecast starts to narrow down in your location. And of course, forecasts are getting more sophisticated in communicating that a hurricane is not a point. A hurricane has wide impacts well away from the center of circulation. So moving ahead, and it's really in that kind of hours time frame that we get more into the impact. So I'll get to that in just a second. With this medium range, you can start to successfully predict when and where an individual storm will develop. You can assess a range of track possibilities and intensity possibilities for an individual storm. But it's still a blurry picture of the hurricane itself. We're not really getting yet into the range where we can say a whole lot about impacts for your location, where you live, or a metropolitan area. And those forecast models, because they just don't do a great job with kind of the structure of the hurricane itself, what it looks like in terms of wind and rain. And the forecast errors are still broad enough that you don't know if an eye wall is going to move directly over you or not 3 or 4 days out. So that's what this last time frame is for, this hours time frame, where you're getting within the last 3 days down to the last 72 hours. Now we're going to drill down into what's actually going to happen location by location. So we still have our global weather models as a tool, but you get into the range within 3 days where you can have hurricane-specific models. You have models that are specifically designed and tuned to do as good a job as possible of emulating complex physics of what's going on between the ocean and atmosphere and the eye wall of a major hurricane. And you also get into the range where within the last couple of days, observations really matter. Sometimes, especially in the last 5 years, people are very blinded to the models are doing this. Well, if you're really carefully looking at the observations in the real world, sometimes you'll note that the models can be immediately wrong. And if they're wrong in the beginning by a little, probably going to be wrong by more going forward with time. So taking that initial snapshot of what the hurricane looks like, using hurricane hunters And radar is very important for getting that initial snapshot of the hurricane right. And those inner storm core dynamics and physics that come into play with those hurricane-specific models are really important for getting the impacts right and getting the hurricane track forecast right. So, and we've really developed a lot of cool new models just in the last 5 years that do a better job of that than ever. So now we're getting into the realm of impacts forecasting. So these colorful figures are something called hurricane threats and impacts products that are produced by the National Weather Service. They're kind of underrated and underutilized. I try to really spot when it's down to the last couple of days of forecasting and use them as a guide to communicate, for your location, for your house, what is the most likely outcome that you're going to get. So at right is every hurricane forecast point that the National Hurricane Center issued for the track forecast for Michael. And you can see the blue lines of their forecast and the red X's for where the storm actually moved. They're right on top of each other. So a great forecast from the Hurricane Center. We don't need to worry so much about track error as it gets down to the last few hours. We're talking impacts, winds, surge, extreme rainfall, and tornadoes. So as it's the day before Michael, I'm taking a look at the observations. I'm taking a look at the hurricane-specific modeling, and we can really start to narrow down. With Michael, the odds of landfall west of Panama City Beach were declining. It was very likely that we're going to see landfall on a swath of coastline between Panama City Beach and Apalachicola early afternoon hours Wednesday. Now it's time for specifics, and that's what I'm communicating in the forecast. Intensity, still tough. That's really kind of our biggest source of error, forecasting error at shorter lead times. At right is a plot of what Michael's forecast wind was supposed to be from Hurricane Center forecasts. What they were predicting at landfall. 3 days before landfall, they were predicting a Category 1. 1 day before landfall, they were still predicting a Category 3 at landfall. And Michael actually eventually made landfall as a Category 5 hurricane. They kind of reevaluated in their post-analysis. So getting rapid intensification and getting the forecast intensity right is tough. At left is a plot of how their intensity forecast scale has been increasing with time. And there is those trend lines are all positive. They're all good. We're moving forward with our intensity forecasting overall. But there's a lot of year-to-year variability. Those especially in the 3 and the 5 day range, those bars jump around a lot. And sometimes, the Hurricane Center is slower to kind of put on the forecast board how much rapid intensification is going to happen. Again, they're getting better with that as the modeling gets better with time. And I think they're kind of shaking some of this more conservative bias for intensity forecasting. But lots of work still to be done in doing that rapid intensification forecasting. And of course, in forecasting the impacts on a location-by-location basis. So within hours of forecast, you do get a good picture of storm structure. You get those usable local predictions for the wind, the surge, and the rain. Weakness, still having a hard time forecasting intensity, especially rapid increases in intensity, even over the very short term. Intensity leaps up and down in a way that models and forecasters find very difficult to deal with. So overall, it's just really important as a forecaster at the 35,000 foot level to just never communicate more confidence than you have in the forecast. Be honest, be humble. This is a humbling profession. You're going to be wrong. You're going to be caught flat-footed sometimes, even in the best of circumstances, but you will never be caught totally flat-footed if you're communicating kind of odds and probabilities. Those odds and probabilities can shift around, but what you really don't want to do as a forecaster is put your foot down and say this will not happen, and then it happens. That harms trust, and it kind of harms the ability of the decision maker to make a good decision, both that time and then going forward in the future. So managing the trust and the relationship with my audience is something that communication is as important, if not more important, than the forecast. You can make a perfectly accurate forecast, but if no one understands it, no one acts on it, it doesn't matter. So in my world, weather is really money. It's money for people deciding whether to open or close schools or institutions for a hurricane. It's money to make your bet on when to buy or sell agricultural commodities. And our goal at Weather Tiger is just to help our clients manage their hurricane risks or their agricultural risks, really on all four of those predictive scales, from months out to just hours ahead of time. And this is Idalia. This was the 2023 major hurricane that made landfall in Florida's Big Bend. And was a Category 4 on approach and weakened, thankfully, before landfall. Came into a less populated area of Florida as well, especially when compared with Category 4 Hurricane Ian that made landfall in 2022 in a highly populated area. So with that, I'm going to wrap it up. If you want to follow along at Weather Tiger this hurricane season, weathertiger.substack.com. I have a newsletter that goes out. There's a free tier. You get a free weekly column. I try to keep it interesting. And then you'll get blow-by-blow forecasts day to day as we have a hurricane threat. So thanks for listening, and I'd be happy to address any questions that I didn't talk or anything else.